Woo! Welcome everyone to the 4th ANER Symposium. I paused because this year we're taking a little bit of a different route. We're going to focus on restoration in the watershed. And as you guys saw from the title of the symposium is From the Bluffs to the Bay. So my name is Jenna Harper and I am the manager here at the Research Reserve. Welcome everyone. It's so good to see so many faces. We're glad to have you here. And not only hopefully for you to learn, but for us to learn from you. And for all of you to connect and share amongst your colleagues that are here. So a couple of housekeeping items. If you haven't been here before, down the entryway platform on the left is the entrance to the Nature Center. And all the way down to the right are the restrooms. There's also a water bottle filling station down there by the restrooms. Today we're going to go through several presentations from our partners and from staff. At the end of the day, we're going to have a brief session on funding opportunities out there. And then tomorrow we will be focusing in on partnerships and potentials for collaboration. So we hope everyone will come back tomorrow and join in that discussion. The meeting today will be recorded. Today and tomorrow will be recorded, just so everybody knows. The mics are all up here. And so when we take questions from the audience, we will ask that the speaker repeat the questions and so that we can record them and have that for you guys later on. We are offering a lunch today. If you haven't already purchased your lunch, you can purchase lunch during the break or at lunchtime. It'll be up in the center. And lastly, I'd like to say, well, wait a minute, before I do that, let me introduce a few staff that you might want to connect with during the meeting. First is our tech guru, Kennedy. If you have any questions, if you're presenting or anything else, logistics, please talk with Kennedy. Other meeting needs, we have Anita and Alicia. I don't know if Alicia's probably running around outside somewhere. Or any of the staff, if you guys need anything while you are here. So lastly, let me wrap up with several thank yous. First and foremost, the staff. Something like this takes months and months to prepare and several meetings and a lot of people's time. So very appreciative to all the staff who are have helped bring this together, who are presenting and facilitating the meeting. I want to thank ahead of time our presenters over the next 2 days. Tomorrow we'll have a special session that is run by the Balmoral group, so thank you guys for doing that. And then lastly, I'd like to recognize lunch and breakfast snacks and coffee were provided in part by the Friends of the Reserve, Loco Catering, and Bayside Coffee here in East Point. So thank you to them. So without further ado, I'm going to ask our first speaker to come on up, and let me do this while I'm jabbering. So we thought it'd be really nice to have kind of an overview of restoration projects in the Panhandle. And because Deepwater Horizon has really shaped a lot of the restoration we've done the last decade, I asked Sarah Ketron from DEP's Division of Water Restoration Assistance, she's in the Deepwater Horizon program, to give an overview of a lot of the restoration that's happened in the Panhandle area and specifically here in the watershed. And we thought this was like kind of a great way to kick off the meeting, to look broadly at everything that's been done, and then we'll dive into some of the special projects. So, Sarah. Thank you.
All right, good morning. Thanks for having me. and I appreciate this opportunity. Let me know if you can't hear me in the back. Just wave at me. I'm on fumes. I've been in New Orleans the past 2 days, running around the city for a Restore Council meeting. But anyway, I do want to thank y'all for listening this morning. I'm going to, as Jenna said, highlight some of the work that we've done in the watershed. And I will say that you'll see my, not mine, the State of Florida DEP logo on the presentation, but as you'll hear in this presentation, we have many partners, including FWC and Natural Resource Damage Assessment trustees, so NOAA, USDA, EPA, all those folks are heavily involved with what we do. So just because you see DEP up here, just know that we don't do it alone. And I will get into that. Where do I point it? Oh, okay.
Try clicking once on the screen to make sure the PowerPoint's in the foreground.
Okay, great. Thank you so much. Okay. All right, so many of you are probably familiar, but just to refresh your memory, in April 2010, the offshore drilling platform Deepwater Horizon exploded in the Gulf of Mexico, causing the largest oil spill in U.S. history. As a result, numerous funding streams were developed to resolve environmental claims. In Florida, state and federal agencies administer funds across the various mechanisms to address damages and restoration. Florida DEP and the Florida Fish and Wildlife Conservation Commission, FWC, are responsible for developing DWH or Deepwater Horizon projects primarily through the 3 funding streams you see on the screen. As I mentioned before, Natural Resource Damage Assessment, Restore, and the National Fish and Wildlife Foundation Gulf Environmental Benefit Fund. So to start with, NRDA, or the Natural Resource Damage Assessment, addresses the assessment of resource injuries and service losses caused by an oil spill and how best to compensate the public through on-the-ground restoration activities. NRDA is administered by 7 trustee implementation groups. So there's 1 in Florida, 1 for each of the 5 Gulf states, 1 state and federal region-wide TIG, so all of the states working together. There's an open ocean trustee implementation group as well. This presentation will focus on the NRDA work of the Florida TIG, which consists of DEP, FWC, who I mentioned, and 4 federal agencies. There have been 73 Florida TIG projects to date. So the next one in the middle there, Restore. This is based on the Restore Act of 2012, which established 5 buckets through which civil and administrative penalties are administered. Buckets 2 and 3 are administered by the Gulf Coast Ecosystem Restoration Council, which is comprised of the governors of the 5 Gulf states and 6 federal agencies. That's why I was in New Orleans, by the way, representing DEP's portion, because in Florida, the member is the governor, and his alternate is the Secretary of DEP. So this presentation focuses on Bucket 2, which has a $1.6 billion allocation Gulf-wide, from which Florida receives funding through a competitive process with other Restore Council members. Only Restore Council members can put forward projects. So there have been 13 Florida Bucket 2 projects to date. Okay, and then the third funding stream you see on the screen there is $2.544 billion in criminal penalties that was directed to the National Fish and Wildlife Foundation, or you might hear me call it NIFWIF, specifically the Gulf Environmental Benefit Fund, which you might hear me call GEBF, to remedy harm and eliminate or reduce the risk of future harm to the Gulf Coast natural resources that were adversely affected by the oil spill. There have been 46 GEBF projects in Florida to date. It should be noted that NERDA and Restore are dispersed over a 15-year period, of which approximately half the funds, not including interest, have been dispersed thus far. So we're in about year 8 this April. Most of the NIFWIF GEBF funds have been allocated. I promise I'm going to get to projects. I just can't skip over the funding part. So I did it. The next few slides are intended to highlight types of projects that have been or are being implemented in Gulf and Franklin counties. Project-specific information can be accessed on the websites maintained by their respective funding sources. I can point you to that later. So this is just a quick map so you can kind of see where projects are in these 2 counties in this watershed. So the map includes a suite of DWH, or Deepwater Horizon projects, NERDA, Restore, and NIFWIF in Gulf and Franklin counties from St. Joseph Bay east to Dog Island or Carabel. So instead of boring you with more funding stream info, because I know that can kind of just get swimming around in the head, we kind of broke it down by types of projects. So starting with land acquisition projects, NIFWIF GEBF funded the Lake Wimico acquisition and management. This was in a partnership between the Nature Conservancy and Florida Fish and Wildlife Conservation Commission, FWC. It is active, and the price was over $12 million. It involved the acquisition and is currently managing 20,161 acre parcel that surrounds Lake Wimico, a natural shallow lake in southern Gulf County. The property is composed of extensive estuarine and freshwater marsh, cypress swamps, and some pine lands that flow into Apalachicola Bay. Acquisition of the property has expanded the Box R Wildlife Management Area and Apalachicola River Wildlife and Environmental Area, or ARWIA. Secondly, there's the NIFWIF funded Apalachicola River Ecosystem Land Acquisition and Management. FWC and DEP are partners at close to, let's just say, 33 million for that one. Would require and manage approximately 32,000 acres of wetlands, floodplains, and nearly 38 miles of frontage along the Apalachicola River. And acquisition would provide protection to approximately 1/3 of the entire portion of the floodplain. Once acquired, FWC would manage the lands as part of ARWIA. And lastly, for Restore, there is a acquisition on the table. It is active, and it will fund phase 3 of the Apalachicola River Ecosystem Acquisition, which comprises approximately 12,500 acres in upper sections of the river in Liberty, Jackson, Calhoun, and Gadsden counties. Once acquired, DEP would manage the land as part of Torreya State Park. Okay, so the next group of projects we'll highlight for you are hydrologic restoration projects. So NIFWIF funded the MK Ranch Hydrologic Restoration with Ducks Unlimited in 2019. It is an active project at $22 million. It is restoring wetland structure and function to MK Ranch within ARWIA. MK Ranch is approximately 6,400 acres of expansive historic tidal marsh in the lower Apalachicola River Basin. For Restore, I think our USDA partners are going to discuss that later, so just know that Restore has some work in there with USDA, which is a member of Restore Council. And then for NIFWIF, there is an Apalachicola River Slough Restoration Phase 1 with Apalachicola Riverkeeper as a partner. And that one is for just over $5.3 million. It is restoring hydrologic connection of 3 degraded slough systems in the Apalachicola River watershed and developing an Apalachicola River Slough restoration plan to further assess current conditions, and quantify the benefits of implementing large-scale slough restoration in the lower Apalachicola River system. And then USDA is going to talk a little bit more about their work in Tate's Hill, I believe, so I'll let them do that, won't steal their thunder. Okay. Moving on to habitat restoration projects. NIFWIF funded the Franklin County Living Shoreline along with the Appalachia Regional Planning Council in 2020. It's an active project. It's over $8 million, creating approximately 20 acres of estuarine reef and facilitating the natural restoration of approximately 30 acres of intertidal marsh along Highway 98 to restore and protect this shoreline from erosion. Also, over $7 million has been funded with NIFWIF Coastal Resiliency funding, which is leveraging for this project. For NERDA, there is an early restoration project, the Florida Seagrass Recovery Project, that started in 2014 with DEP. It is a monitoring project at $2.6 million. It restored approximately 2 acres of seagrass scarring in St. Joe Bay Aquatic Preserve by installing sediment tubes. For Restore, NOAA led a Money Bayous wetlands restoration in 2015. The project is in progress and it's $1.2 million. It implements hydrological restoration on approximately 1,000 acres of Money Bayou Basin wetlands on the St. Joseph Bay State Buffer Preserve. And finally, just outside the doors here, NERDA funded an early restoration project. When I say early restoration, I know I kind of skipped over that, but if y'all have questions about what that is, it just means it was pre-settlement. So in 2016, there was a settlement that allocated NERDA funds, but prior to that, $1 billion was released for what we call early restoration. So for early restoration, Florida Cat Point Living Shoreline Project began in 2014. It completed and is now in monitoring for $1.2 million. It employed living shoreline techniques to reduce shoreline erosion and provide habitat off of East Point, Florida. The project activities include expanding an existing breakwater by creating up to 1/3 of a mile of new breakwater that provided reef habitat and created approximately 1 acre of salt marsh habitat. And if you haven't been over to see it, I encourage you to do that while you're here. It's a neat project. Okay. So for water quality restoration, the Florida TIG funded a NERDA project in its Restoration Plan 1 for the City of Carabelle's Lighthouse Estates Septic Tank Abatement Phase 2 program. It was $3.2 million, and it's actually wrapping up over the next 4 weeks. So it will improve water quality in Apalachicola Bay and St. George Sound by connecting homes near the bay currently served by septic systems to a central wastewater treatment system. For Restore, there is an Apalachicola Watershed Agriculture Water Quality Improvements Program. DEP is implementing it along with partners DAX and NRCS. The price tag is $2.2 million, and it administers cost share funding to assist participating producers in Jackson and Calhoun counties with implementation of state-adopted BMPs that are consistent with, I didn't define who NRCS is, but it is I'm blanking. I know you guys. Is there anyone from NRCS in the room? Natural Resource Conservation Service. Thank you. I just needed a little push. It'll include items such as guidance systems, precision oil sampling, remote sensing techniques, variable rate and section control technology, and irrigation system retrofits. That's a mouthful. And finally, the Florida TIG is funding a program or a project with the City of Port St. Joe for stormwater improvements. That started in 2019 and it is in progress for just under $1 million. It'll provide stormwater improvements in Port St. Joe and includes traditional stormwater control measures and development of a stormwater master plan for the city. Am I doing okay on time? So, I'm going to talk a little bit about oyster restoration, and starting with the NIFWIF GEBF Apalachicola Bay Oyster Restoration, led by FWC, that was started in 2013. It is active. It is just under $4.2 million. It is enhancing approximately 18 acres and improves the management of approximately 3,000 acres of degraded oyster reef habitat across a range of salinity levels. NIFWIF GEBF also funded the Apalachicola Bay Oyster Reef Restoration Phase 2 in 2019. It is active. This is over $20 million, and it will implement up to 1,000 acres of oyster reef restoration in Apalachicola Bay using results from the NIFWIF Phase 1 previous investments in the Apalachicola Bay oyster restoration research to inform the design and management of this reef restoration initiative. There is also a NERDA Early Restoration Florida Oyster Culch Placement Project. This is in 2014 and it's now in monitoring for over $5 million. It enhanced oyster populations in Pensacola Bay, St. Andrews Bay, and Apalachicola Bay through the placement of an estimated total of 49,000 cubic yards of culch material over approximately 210 acres of previously constructed oyster bars. And finally, for Restore funded in its funded priorities list 1, Apalachicola Bay Oyster Restoration. DEP, it started in 2015 and is now complete. The price tag was approximately 4.7 million. And it expanded the NERDA Early Restoration Project within Apalachicola Bay by placing an additional 50,000 cubic yards of culch material for oyster populations over approximately 251 acres. And I just want to say, for a lot of these projects, I know that there are folks in the room that have assisted with these. So I just want to take a moment to thank you all. I know we've got folks that have helped with monitoring with the seagrass projects and the oyster projects. And it's just really lovely to see folks come together and do this work. And finally, I'll touch on, well, it's not finally, sorry. There's exciting stuff in here. Just making sure, okay. So I am gonna touch on some of the recreation projects that DWH has funded. So for NERDA Early Restoration, it funded a scallop enhancement for increased recreational fishing opportunity in the Florida Panhandle. That's the name of the project. This was led by FWC in 2014. It's in progress for $2.3 million, and it enhances local scallop populations in targeted areas in the Florida Panhandle, primarily St. Andrew Bay, St. Joe Bay, and St. George Sound, through the harvesting and redistribution of naturally occurring juvenile scallops, supplemented with stocking from a commercial scallop hatchery. Scallop populations in Gulf and Franklin counties were targeted to reduce the risk of population collapses in current recreationally harvested areas. So post-settlement, like I said, the Florida TIG developed restoration plans. So we're actually working on our third restoration plan now, but the second restoration plan was habitat focused, and it funded a Florida Artificial Reef Creation and Restoration Phase 2. FWC led this in 2021. It's in progress for $10.3 million. It implements artificial reef development off the coasts of Escambia, Santa Rosa, Okaloosa, Walton Bay, Gulf, and Franklin. That's how it made it into the presentation. And Wakulla counties through the deployment of rock boulders, prefabricated concrete, or design modules. Representative target fish species enhanced by this project include amberjack, red snapper, vermilion snapper, triggerfish, kingfish, cobia, gag grouper, scamp grouper, and other reef fish and grouper and snapper species. In addition to these projects, there are a handful of other NERDA-funded projects in the area that restore or enhance recreational opportunities through improved coastal access, such as parks, boat ramps, and facilities, and piers. Thank you. And lastly, I'm just going to touch on the sea turtle, bird, and marine mammal activities, just to let y'all know that there are multiple NERDA and NIFWIF GEBF projects focused on the restoration of shorebirds, seabirds, sea turtles, and marine mammals on the Gulf Coast of Florida, including in Gulf and Franklin counties. So what is ahead? So as I mentioned, the Florida TIG will continue implementing NERDA projects through their restoration planning efforts. We are actually poised to release a draft of our Restoration Plan 3 this month, or next month. It's Leap Day. I don't know what day it is. For Restore Bucket 2, we're continuing to implement our projects from our funded priorities lists. To date, there have been 2 activity-focused funded priorities lists. We are currently working on the 4th FPL or funded priorities list to decide, along with our members on Restore Council, what we're going to fund. And for NIFWIF GEBF, implementation of projects and planning the use of remaining funds. So I just want to say thank you all for listening. I know it was a lot of information thrown at you. I'm going to be here this afternoon, and I'm happy to be able to share this with you. Thank you so much.
Good morning, everyone. My name is Megan Lamb, and I'm the stewardship coordinator here at the reserve. I will be your MC for the morning session. We're going to be talking about some upland management and restoration projects first. So up first, we have Kathy Ricketts. Kathy is a wildlife biologist and the preserve manager at the Nature Conservancy's Apalachicola Bluffs and Ravines Preserve. And her talk is called A Crowning Moment for the Emperor, Juvenile Eastern Indigo Snakes at the Apalachicola Bluffs and Ravines Preserve.
Thanks. Well, I don't have to say who I am now, so that's cool. I did change my title a bit because it was super long, and I was like, all right, I've got to shorten that. So, yes, I'm here today to share this story of the beginning of our happily ever after, basically, which I've shown here. I figured I might as well just get right to it. So on the left, we have a nice view of some intact, restored sandhill habitat with wiregrass in the front and pine, longleaf pine in the back. And then on the right, we have one of 2 juvenile wild-born eastern indigo snakes that were documented on the preserve last fall. If you don't know, the indigo snake is known as the emperor of the forest. So that's where I got my title from, in part because it's an apex predator in this ecosystem, and also because it's the longest snake native to North America. So these guys can get up to more than 8 feet long. And so how do we get to this kind of beginning of this happily ever after, which thankfully is not a fairy tale, it's real. And so this is going to be a very high level overview of the restoration work that's occurred since the Conservancy acquired the property about 40 years ago. So I'm not going to get into a lot of the details about the restoration work and all of the staff time and partner projects that went into getting to this point, because each of those things would be like a whole separate presentation. So if you need more details or want more information, feel free to contact me later or talk to me later. To set the scene for the story, let me show you where the Bluffs and Ravines Preserve is located if you're not familiar. So we are definitely on the Bluffs part of the Bluffs to the Bay scene that Jenna mentioned earlier. So we're up here just north of Bristol, Florida. This preserve is part of a network of about 25,000 acres of conservation land. So Torrey State Park is right here, adjacent. We're these two orange pieces right here. We also have Beaver Dam WMA, which is adjacent to the preserve here on the west. And then in between our two sections is it's pretty sizable 650 acre conservation easement. And then of course down here is Aner. So we're definitely up towards the north end of the river. So let me zoom in a bit closer to where we are. So we have two main sections of the preserve. This northern piece is known as the Sweetwater Tract, and that was acquired in the mid-'80s and early '90s. I'm not going to talk too much about that piece today because all of this restoration work in the main area for the indigo snakes is down here in our Bluffs tract, and this was acquired first in the early 1980s. It's upland sandhill communities with the ravines interspersed, and so that's the restoration part that we're focusing on today. That's when the Nature Conservancy stepped into this story, but of course there's a bit of a prequel, right? What happened, what was going on across the landscape before the Conservancy took over? So I've got a few time series of a few pictures of aerial imagery back in time. And this is the southern piece, a little southern portion of the preserve. So if anybody's been there, and I put this on here for reference, this is the Garden of Eden Trail that you can access just north of Bristol. So this is a trail you can hike out to Allen Bluff here on the river. So just for your frame of reference. And then I included these red polygons, again, just so we can kind of locate ourselves when I talk about some of these pieces that are our management units that have just numbers as their IDs. So as with much of the landscape across this part of Florida in the 1800s, the non-Native American people were using this landscape for subsistence farming and grazing. But in the 1940s, started to being logged more heavily for longleaf pine. So this is a picture of the preserve, and these upland pieces here are the sandhills, and then these are the ravines, if you're not familiar with what this looks like. So each one of these has a creek heading towards the river, which is right over here. So it was heavily logged, but for longleaf pine. However, this was like industrial timber operations, so it wasn't so terrible for the landscape, right? The biological characteristics of the land was generally intact, with the exception of less pines. Then moving forward into the 50s, so now I've added this piece right here, this aerial imagery. So this is still 1940. This is 1957. The clear cutting of this area began. It became more of a focus on industrial timber, planting offsite slash and sand pine. The result of these timber clear cuts was windrowing. So now I've added this 1964 piece here where you can clearly see the windrows that were created to facilitate, planting pines in between. And what windrowing is essentially piling up all of the vegetation into these rows, leaving the spaces in between basically devoid of ground cover, disturbed seed bank, et cetera. So the nutrients that are remaining in this blocks are concentrated in these rows. This creates some micro topography that wasn't there before, with these rises of vegetation striping across the landscape. So that can interfere with whatever fire might have even occurred, but generally they remove fire from this landscape because sand pine and slash pine don't like fire and can't tolerate it the way longleaf do. So then that disrupted the fire regime, ground cover's gone, nutrients are removed, facilitating also hardwood increases of hardwoods, particularly turkey oak with less fire. So this is basically the state of the whole entire preserve by the time the Conservancy acquired it in the 80s, except for a few pieces. So like right here, this unit 20, and down here, unit 5, I just show a sliver here. These and a couple other places were not windrowed for whatever reason. So this became important later on for the Conservancy's restoration efforts. Here's a more recent image, so you can see the legacy of these windrows. Now, this is even after restoration work, which I'll show you later on. There was a 20-year period where these windrows were tried to restore these windrows back and level them down. But they're still visible. But nevertheless, the windrows themselves were a source of wiregrass clumps that could be transplanted, which I'll speak about in a minute. And then also these same areas. So right here, the area that wasn't windrowed, this whole section down here, that was also a source of native ground cover seed, and kind of giving us an idea of the reference conditions to move forward with restoration goals. Early on, though, it was known and recognized that prescribed fire was going to be a huge part and a critical piece, restoring the historic fire regime to the landscape. So in 1984, the first Nature Conservancy applied the first prescribed fire to the property, and for the first 6 years, they burned about 4,000 acres across 62 units. This is not a picture from 1984, but you get the idea. Most of the burns occurred in the growing season, a few were in the dormant season. One example, again, I'm just giving you a very brief overview of all this work that's been done, but one early strategy was to thin the off-site pine and then replant with longleaf at 300 trees per acre. I mentioned that there was some wiregrass remaining in those windrows, so they could transplant some of that wiregrass into the restoration areas. They also used wiregrass seeds grown in the nursery, shown here, again, not from 1984, but this is what the process looked like, and direct seeding. So this is more from like the heyday of the nursery at ABRP. We supplied plugs to partners across the region and for ourselves in restoration work. But ultimately what that southern piece of ABRP became was a living laboratory for testing, evaluating, and adapting a number of strategies over this past 40-year period to try to figure out the most efficient way of restoring the sandhill habitat. So many research projects were conducted. Some involved, for example, seed sowing techniques. What's the best way to get a large amount of wiregrass across these blocks? Is it going to be direct seeding? Do you then pack the seed down or just leave it on the ground as it is? Or do you blow it around like with machines trying to simulate like wind dispersal or not? Another piece of work looked at bare root planting of pines versus containerized. And then again, there was windrow restoration, which I'll show you next. So that's totally glossing over a lot of work. I can't even stress that enough, how much work this really means. So this windrow restoration over from 1990 through at least 2008, each year a section of these windrows were flattened with bulldozers to try to remove that microtopography and maybe distribute the nutrients that were left in these places a little bit more just outside those those hills. What we've come to now and is used currently, this is the main strategy that TNC uses on our site, not so much now, but certainly on partner sites, in particular Torrey State Park. So what we do now is there's mechanical site prep. So as you can see, this landscape is completely cleared. This usually occurs pretty close to when we're going to be like reseeding and planting so that undesirable vegetation doesn't have a chance to grow back. Excuse me. Sites that we're going to use for donors, for the sources of ground cover, mostly wiregrass, but other native forbs. Those are burned in the growing season to ensure that we have maximum seed viability when they're harvested in the fall. So you may have seen these if you've been around the Panhandle much, but this is a tractor with a flail vac, so it's basically a giant seed vacuum. And so in the fall, when the seed is mature, we go out and harvest the seed. So this is an example of past collection. It's usually like 4,000 to 8,000 pounds per year, depending on which donor sites are being used. And then later on, after the seed collection season spans about, November, December, just depends. Pretty soon after that, then folks are out there with these grasslanders planting the native seed in these areas, which is going to be quickly followed by containerized longleaf planting. So that whole process, occurs over a 4 to 5 month period. And, sometimes we'll do as much as 200 acres a year, just depending on, how much land can be prepared. So again, this is not happening so much on ABRP proper anymore. And we will use this method to fill in gaps where, previous efforts maybe weren't as successful as we'd hoped. But a lot of this work right now is being done on the state park and other partner properties. We are using this on the Sweetwater tract as we move toward restoring that northern piece. The seeds that we collect, we use for ourselves and partners. We also just share them through like ARSA agreements and grants. So for example, Tyndall Air Force Base got a considerable amount of seed that we collected this fall for some of their own work that they're doing post Michael restoration. So that is a quick look at the physical habitat ecosystem restoration. The other part of the story is the wildlife component. How did we get to a point where we have this habitat, but what about the wildlife and getting the snake back on the landscape? Because the last documented occurrence of indigo snakes in that part of the Panhandle was in the early to mid 80s. And that was just a single individual, so not necessarily an indicator of a robust reproducing population. So again, early on, people recognized that there were going to be certain wildlife species that were going to be indicators of progress towards sandhill restoration. And the two chosen for ABRP were the Sherman fox squirrel and the gopher tortoise. So I'm not going to talk much about or anything about the fox squirrel because that's not really relevant for the indigo snake, because if you know the indigo snake, then you know it uses gopher tortoise burrows like so many other creatures do, in particular in the winter, to thermoregulate up here in the northern part of its range. So they first started surveying formally for tortoises in 1992. There was another survey in 95 and one in 98, and these were your standard belt transect surveys that covered about 5% of the preserve. And within that time, there was a significant increase of tortoises from one survey to the next, indicating that, we were moving in the right direction for restoration. There were some additional surveys done after that, but just to give you an idea of where we are now, we did some work last August to look at gopher tortoise burrows across the preserve. And this was not the objective of this survey was not to get an estimate of tortoises, density, population, etc. It was focused on finding dense clusters of burrows that were active to inform our indigo snake monitoring. So we can't compare these data to the earlier surveys, but you can see that tortoises are pretty consistent across the preserve. And I want to point out here that, you know, like areas in 5, 6, and 7, or some of these other areas that are empty, it's not because there's no tortoises there. I didn't show the tracks of our survey because that would have made this map too convoluted, but I just want to say that we didn't get to survey all of the preserve. So don't assume because there's empty spaces, there's no tortoises. It's just we didn't get to survey every place this past summer. All right, so because of our healthy gopher tortoise population, all of that restoration work that went on, in 2017, ABRP became the second site in the northern part of the federally threatened snakes range where we could re-release them onto the landscape. The first place was in southern Alabama. And so when we released those first groups of snakes, they were implanted with radio transmitters to give everyone an idea of where the snakes were going and how they were using the landscape. So what that found was, in the summer, they were in the ravines where it was cooler, plenty of prey, but in the winter, they were up in the uplands using the tortoise burrows. Now this just happens to be a picture of the release. So releasing a snake into the burrow in April every year. And then this, I really put this picture up here too to show you a camera. So select burrows have cameras focused on them to document animals, including snakes, using the burrows. We'll also use burrow scopes to find snakes. And as of last year, we've released 126 towards our goal of 300. So the primary survey season is October to March. This is our field biologist, Michelle Huffman with the Central Florida Zoo. She's been with the project from the beginning, doing all of our field monitoring. In addition to those cameras that we have at burrows, we also have drift fences, and there's cameras pointing at the ground under each of these buckets to capture snakes slithering by. And so with all this monitoring, you know, we figured for sure it was going to be Michelle out in the woods that found the first juvenile, whenever that would be. But no, the snake made it easy on us. It was just hanging out at our shop last September on the driveway. And my coworker here, Ronald, pulled up and he's like texting me and my other coworker, there's a baby indigo on the driveway. We're like, what? No, come on. But here it was. She was, I should say. So that was super exciting, although my coworker is not drinking a beer in celebration. That is sparkling water, I promise. So luckily for us, Michelle was able to identify it as a female. This is a picture of it before she released it back into the wild. Of course, it was implanted with a pit tag too. And a couple weeks later, she actually was out in the woods in a more typical place you would expect to find a snake, and she found our second individual. And so that was really exciting because, you know, 7 years later, 6 years later, we're finding evidence of, you know, the beginnings of hopefully a self-sustaining population of this threatened species. Both of these, she estimated, were 3 to 4 months old, you know, so born last summer, May, June of 2023. So that, like I said, that's sort of the beginning of our happily ever after. The epilogue includes some additional monitoring techniques that we're trying to experiment with to expand our scope and capabilities. We have a solar pit tag reader that we've deployed in July of 2023. We're looking at some feasibility of using eDNA. And then to go through those millions, literally millions of pictures that Michelle has on the game cameras. Soon we'll be releasing this citizen science project where we have all of our photos from the cameras on the web through Zooniverse. And so anybody can log in and help us scroll through all of our game camera pictures. So hopefully soon. It's like in the last phases of testing. So anyway, thank you very much. I know that was a lot to cover in a short amount of time, so feel free to ask me any questions or contact me later.
Yeah. Thank you, Kathy. To keep us on schedule, we're going to skip questions, but Kathy will be here the rest of the day. And we will move to our next
speaker.
Lexy Preheim works in the stewardship section here at Aner, and she is going to be talking about restoration through invasive removal this morning.
Right, good morning everyone. Unfortunately, I don't have any cute pictures of indigo snakes in my presentation, but that was awesome, Kathy. As Megan mentioned, I work in the stewardship department here at Aner, and today I'm going to be talking about a case study that we did on Triadica sebifera, Chinese tallow tree around our nature center area. So this is going to be going through some restoration through invasive removal. So to get things started, a little bit about Aner's managed lands. The reserve boundary is around 235,000 acres. On this map here, the boundary is in orange. It does actually go farther north than what this map shows, but this map really focuses more in on our directly managed lands, which is around 7,000 acres. And on the map, that's everything in blue with those dotted lines around it. Except for the Lower River Marsh and Little St. George Island, Aner's managed lands are small, highly fragmented, individual parcels embedded or adjacent to residential communities. So on St. George Island and East Point, you can see a lot more of those smaller parcels compared to the other two. And all of this land provides public use, recreational opportunities, and serve as research and monitoring sites for both our stewardship and research departments. So one of the things that the stewardship department is tasked with is managing invasive species. So the main management goal is to restore the original presence of native species. And we do that by prioritizing sites and species of most concern and long-term monitoring, removal, and maintenance. But with that, like just about anything, comes challenges. The main one is the diversity of species. Here in Florida, we have a lot of invasive species, and they are very, very resilient, which also kind of ties into our second point, treatment effectiveness, and those two go hand in hand. I mentioned a little bit in the previous slide, we have a lot of small parcels adjacent to residential communities, and that kind of poses the challenge of we can continue to treat invasives off of state lands, but if homeowners also have invasives, it's just a matter of time before those creep back onto state lands. So you kind of just get into this circle of treating. So educational outreach is a big component to that challenge. And then I'm sure a lot of people in this room can agree with this last point, whether you do invasives or other research, but limited resources, staff, and accessibility to sites. Our stewardship department here is a team of 3 people, so we really do have to go up to that second point and prioritize sites and species of most concern. But today I'll be talking about Chinese tallow tree. This is just a little overview slide if you aren't familiar with the species. It is native to China and Japan, was originally cultivated as an ornamental. It's a resilient species found in both wetland and upland environments and can grow in open and closed canopies. And it reduces the diversity of native plants, just like about any other invasive species does. A couple key characteristics about it: it has simple alternate leaves. In this first picture here, you can see the leaves are red, so in fall time, the leaves do change colors, which is a very distinctive characteristic living here in Florida. You don't get to see that too often. They have small yellow flowers and white popcorn-like seeds, which is where it gets another one of its common names of popcorn tree. So we completed a case study, and the main objective was to manage an invasive species and achieve a maintenance mode, specifically on Chinese tallow. The location is the Aner Nature Center. So on this map, you can see the Cat Point Aner parcel. Now where that purple circle is pops out, but that's just right outside of where we're sitting today. It's about a 15-acre area, and the habitat is marsh surrounded by pine flatwoods. And this was a higher priority for Aner to treat at the time because you can see the boardwalks that go through the area. People who are coming to the nature center, we really wanted to show what that natural habitat should look like. The timeline of this project was 2014 to 2023. And methods used was surveying and taking spatial data at any invasive species point, and then treating the Chinese tallow tree by mechanical and chemical treatments. That was done with basil bark applications with 20% triclopyr with oil, hack and squirt applications with 50% method, and hand pulling when deemed necessary. So throughout this project, the total trees that were treated were 2,759. And the main thing to really show in this is at the beginning there were a lot more trees being treated, and then you can see that downward trend as time goes on. We kind of get into that maintenance mode. And another thing to point out was at the beginning of this project there were a lot more staff time and resources being put into this area, but now that we are kind of in that maintenance mode, we can focus on treating invasives on other managed lands. So one of the parameters we took was tree maturity, so mature saplings and seedlings. As you kind of expect to see in the beginning of this project in 2014, 15, and 16, we do have a lot more of those mature trees, and you kind of see the downward trend of that. And then you get the spike of the saplings and seedlings from the leftover seed bank that's in the soil. And then as those get treated, we also see that downward trend. And then I'll play here for you all. I've got a time-lapse map, and the larger the point, the more stems that were treated in that area. But let's see if this works. All right, so in 2014, you see all those red mature points, and as the different years pile on, it's kind of cool because where those original mature trees were at is where all those saplings and seedlings start popping up in those areas. Right. And then the last parameter that we took that I'll be talking about today is treatment type. So this was herbicide versus pulled, and the main thing we really want to show is we kind of had that transition from in the beginning of the project, there were a lot more mature trees, a lot more herbicide being used, and then as far as our management goal, we wanted to get to the transition of where we were pulling more seedlings instead of using herbicide. So you can kind of see that trend from the graph here, and I've got the same sort of time-lapse map I'll play for you. So if you kind of remember back to the previous slide where those original mature trees were, is where that herbicide is being used, the orange points, and then as time goes on, we get more of those blue pulled points around those same areas. There we go. One thing I did want to mention is hurricane impacts. So during this case study period, there was the 2018 Hurricane Michael. We have our case study area down here. By the time Hurricane Michael hit, our case study was kind of in the beginning stages of that maintenance mode. There weren't a lot of mature trees. But something to point out is just across the street at Millender Park, we weren't in that maintenance mode at that point. There were mature seed-producing trees. And so with the wave impact and salt intrusion, we did have a reduction of Chinese tallow, but we also had a reduction of the native trees, which opened up the canopy and invasives love open canopies. So it introduced some new species to the area, such as air potato and primrose willow. So moving forward with management plans, we definitely think about how hurricane impacts will impact areas as far as what we decide to treat. In the end, this is a very, very small case study. It's only 15 acres, but it does show a success story of where we have an invasive species and getting that single species into more of a maintenance mode. So we're going to continue doing yearly monitoring and data collection. Luckily, this area takes a lot less time to survey since there isn't as many Chinese tallow tree. And then also continue doing invasive surveys on other managed lands. And we're going to hopefully start using some drones in some of the surveys. We recently started a drone program here at Aner, so we're just kind of getting our feet wet with what all you can do with the drone. And there's a lot of cool applications with drones in science, specifically some research that has come out with using drones for invasive surveys. So hopefully that can be a tool we can use, especially in those hard to access areas like the Lower River Marsh, potentially doing some baseline studies there. Education outreach is a great tool, and we will continue doing that. And we're hoping to incorporate invasive monitoring into our site stewards program. So within the last year, the stewardship department started a new volunteer program called Site Stewards. And it's where volunteers go out to sites that they can access by land and report on survey 123 things such as vandalism, trail maintenance needs, eagle nest watching, wildlife encounters. So we're hoping to do some more trainings with them this coming year with invasive ID, and hopefully have more feet on the ground to take points and kind of continue that early detection, rapid response that we all strive for. And with that, I want to say thank you, especially to the stewardship department here at Aner, Megan Lamb and Rebecca Keller, and then also to Caitlin Snyder for helping put this presentation together. I'm just presenting on this, but a lot of this work was done far before my time here. So thanks to anyone who's helped out to this project, whether they're in this room or before that. And with that, I'm going to transition the rest of my time to Diane Alex, who works with the Nature Conservancy, who's a great partner for us to have, and she's going to talk a little bit about the SISMA program.
Thanks, Lexy. If you haven't heard of the SISMAs, that stands for the Cooperative Invasive Species Management Area. And ours is from Bay County over to Leon and Wakulla. And this is a group for managers and the public to get together to work cooperatively to manage invasive species. And how do we do this? Through a variety of work days, training, public outreach, and this is our website, which will be updated soon. And there's my contact information if you want to be added to mailing lists to hear about more opportunities. A couple specific things that we're working on in the near future include updating our early detection species lists for species for us to be aware of if we see that aren't established in the region and could become a threat. And then also we're looking for properties for work days. If you have something, like say you have a staff of 3 and you're like, man, I could knock this out with 10 people, that's something we're wanting to coordinate across the region, and then also increase our training opportunities. So anyway, if you're interested in getting involved, shoot me an email. Thanks.
We have time for one question if anyone has a quick one.
You think that method could be applied to sweet gum? Maybe.
No, I do not have an answer for that. Yeah.
We have it on our preserve. I want it gone.
Yeah, any of the species we don't really deal with that much. We definitely go more towards the invasive program at FWC for guidance. So that would be someone I would reach out to for that.
And sweet gum won't be covered by FWC, that's a native species.
Can be invasive
Yes.
up in the
Not
uplands,
invasive.
sure, yeah.
Right, well, thank you, Lexy and Diane. And up next, we have Jean Huffman. Jean is a researcher and the founder of the Tall Timbers Tree Ring Lab at the Tall Timbers Research Station and Land Conservancy. And Jean is going to talk to us today about restoring uplands and wetlands with fire. Take it away, Jean.
Okay, I'm not going to be giving a case study exactly here. I have a lot of experience with management of fire and restoration, and fire is incredibly important and vital to all kinds of natural areas restoration, uplands and wetlands. And I've worked with restoration of Florida dry prairie. Let me see, does the mouse work? No, it doesn't. Florida dry prairie in southwest Florida, restoration of uplands and wetlands at the buffer preserve, and in the St. Joseph Bay State Buffer Preserve, and also now with Sand Hill restoration in Gadsden County on private land. And I've also been able to do research on different aspects of fire and organisms, plants, fungi, but currently it's these stumps here and fire history from stumps that's, whoops, can I go back? There. So what I'm going to present today is a little different. I'm going to present one tree ring based fire history study, and then one example of the relevance of the results of that towards management and restoration, basically of wetlands at the buffer preserve. So, like I said, fire is incredibly important and we manage it. But what do we base our management on? Tree ring fire histories can shed a lot of light on what fire regimes used to be like and hopefully help with current management. So the study that I'm going to be presenting is from Tyndall Air Force Base. And a lot of other people worked on this. The southeast, this whole sort of longleaf pine savanna, it's actually mixed with some shortleaf as well and embedded wetlands of all different kinds. It's an area that has a lot of prescribed fire, but very few tree ring reconstructions of fire. There's hints to what historic fire regimes were like from the organisms that live there and have evolved with the system. Their life history traits say a lot about what fire was like. And the climate of, super lot of lightning ignitions and also a long human history of fire ignitions. It's a very fiery place, but like I said, very few tree ring reconstructions. There's hundreds, maybe thousands of fire history reconstructions in the West, but very few in the Southeast. So this is going to be in longleaf pine flatwoods, and I did a previous study on Little St. George Island in slash pine flatwoods, and then another study at the buffer preserve, but it's kind of was a preliminary study, but this one is more comprehensive. So one of the reasons there haven't been fire history studies in the southeast is because longleaf pine are very fire resistant, and so you don't see a lot of fire scars. And what we discovered actually at the buffer preserve when I was there is that if you cut very low on the trunk, that's where the scars are located. The study that I'm going to present today is at Tyndall Air Force Base. And this site is used because, well, first of all, these kind of stumps, these old growth longleaf pine stumps are very rare because there's been a lot of stumping, that they were harvested, you know, the old growth is gone, but these little final remnants of what was here are the stumps. And this site at Tyndall had a whole lot of stumps in a small area, so good for reconstructing fire history. And we actually excavated these stumps because the scars are very low and you can't chainsaw like at ground level. So they were collected, and this is a stump from the buffer preserve. Shows you the kind of stumps that contain this kind of information. I'll go through the methods really fast because I don't have time. But first, you know, the first challenge to this was dating these and using dendrochronological methods that I can't go into. We produced a chronology. Actually, the chronology was produced from things collected at the buffer preserve, and then it was used to date the Tyndall sections and process the fire scars. And was really amazing what we found is that the chronology, so these stumps dated from the late 1400s up until 1839. And we found fire scars from 1516 to 1819. So this produced over 300 years of fire history. So this is how you present fire history data. So each horizontal line is a tree or a stump, a tree stump, and each vertical line is a fire scar. And then the bottom is a chronology. So you can see the fire frequency for the whole period of record here. And then for the period where there are many trees recording. And you see that MFI is mean fire interval. So the mean fire interval was 1.0 to 1.2 during that period. That's really significant, much more frequent fire than we ever expected, hyper frequent fire. In fact, sometimes there was more than one scar season in a single year, indicating that there were 2 fires in a year. So the second aspect that we can learn about with fire regimes from fire scars is the seasonal timing of the fires, and that's done by where the scar occurs within the growth ring. And we've done studies looking at when trees grow, like over 12 years of monitoring tree growth of longleaf pine at the buffer preserve, so that we could see where within the tree ring corresponds to what season and time. And don't have to go into that, but what we found is that the fire scars in this fire history study occurred, 80% occurred in basically May to August, which is during the peak lightning season, the beginning of the lightning season. So summary of the results are that for this period of time, the fires were extremely frequent, occurred mostly in the early lightning season. And the third thing here is that they occurred mostly in this period of transition from the dry spring to the wet summer, and so they occurred when it was very dry. And like I said, we now determine the fire regimes on natural lands, and hopefully this information is useful and useful in terms of restoration as well. So how does our current fire management generally vary from historic regimes? And that's clearly the past. It was extremely frequent, and now many places are fire excluded, and almost everywhere is less than annual. There is actual annual burning up in the Red Hills that's been pretty continuous, or annual to biannual. But in general, we need to increase the frequency of fire. And seasonal timing is very different. In the past fire regime was mostly this early lightning season, and current it's mostly dormant season, or outside of that peak time. And one of the reasons it is mostly outside of that time is because people don't burn when it's dry. Generally. But I've actually been involved with 2 restoration projects where we've used this dry growing season fire to restore wetlands. So recent changes in fire regimes in this region, fire exclusion, especially at the coast, 60 years of silvicultural burning, which is cool season when there's high surface water levels, dormant season fire. And the effects of this in the landscape all over are increases of woody plant species in the uplands and wetlands. Less fire that moves across wetlands or moves into wetlands, and negative effects on plants and animals that have evolutionary history with this kind of the pre-settlement fire regimes. So if they have life history characteristics that depend on that kind of fire regime, they tend to be in trouble. So uplands, more woody, palmetto, etc. But the example I'm going to talk about is wetlands and rare species, and mainly from my time managing the buffer preserve. So this is just some shots of fairly good condition fire managed wet savanna transition zones. But all over this region, what you find is a transformation of the wetlands into shrubby, tie dominated. This is just where we cut a kind of a cross section. You could see the shrub invasion of what was an open wet savanna like in the previous picture. So when fire regimes changed from being during the dry period very frequent, it kept these wetlands open. When it changed to being dormant season wet or infrequent, this was the result. And this is all through the basin. And like I said, the species that are particularly adapted to those zones became rare species. So 16 of the 21 rare plant species when I was at the buffer, there were 21. There may be more now, but 16 of them occurred in that transition zone between cypress wetlands and pine flatwoods. And they're rare because of this shrub invasion. And of course, flatwood salamanders also have a life history that's very connected to the pre-settlement historical fire regime. They were a common thing, like red cockaded woodpeckers were very common, flatwood salamanders were very common, but are almost extinct now, almost functionally extinct, and that's because they needed habitat that had this kind of dry season, frequent fire. And so occasional fire in this dry early growing season is extremely important for restoring these areas. And we were able to do that at the buffer preserve, do fires that occurred when it was extremely dry, burnt out the duff that accumulated during these decades of altered fire regimes, and really restored the rare plant populations and the habitat in general. But the key to this is having frequent fire afterwards. So the kind of the principles of what we found with the historic fire regime, if you can apply that in the existing landscape, which is highly altered and is very challenging, and I recognize, but that is essential for this kind of restoration of both uplands and wetlands is fire. Fire is very important. And thanks to all the people who helped with this study. And that's it.
We have time for a few questions, if anyone has questions for me.
Were you able to get a sense of fire severity from the size of the scars?
Well, when fires are annual, they tend not to be severe. If you have a bigger scar, would indicate a more severe fire, but it's probably caused by a branch falling. Like after hurricanes and things like that, you have downed wood next to another tree, and that makes a severe fire. So I'd say that, historically, there weren't a lot of severe fires because they were so frequent.
Any other questions? All right, well, thank you so
Okay.
much, Jean. We are gonna take a break, and we're gonna come back here at 10:50, and we're gonna transition from the uplands into the river floodplains for our next session. During the break, if you registered for lunch and you need to pay for your lunch, you can do so at the Nature Center. And also, our poster session is at lunch, but the posters are up already in the Nature Center as well, so please feel free to visit them. And see everyone back here at 10:50.
Welcome back, everyone, to our next session on river, forest, and floodplains. My name is Ethan Bork, and I will be introducing our next speakers. First, we'll have Paul Medley, Gulf Restoration Program Specialist with the USDA Forest Service, co-director of the Center of Spatial Ecology and Restoration, and he'll be talking to us today about Tate Hell's hydrologic restoration.
Good morning, everyone. It is still morning, right? Thank you very much for inviting us to come to talk to you about a few of the restore projects we've been involved in over the years, and hopefully a few more years to go. We're very excited about these projects, and before I get started, I do want to give a shout out to Dr. Jason Drake, who's my colleague from the Forest Service, partner in crime in these projects. And he's got some really mad LiDAR skills, so just saying. Tate's Health Strategy 1 and the Apalachicola Regional Restoration Initiative Strategies 2 and 3 all kind of run together. They build on one another to set the stage for the next portion of this. We just wrapped up Tate's Health Strategy 1, and we're just now starting Strategies 2 and 3. So Tate's Health Strategy 1 was a two-part project. The implementation part was led by the Florida Forest Service on Tate's Health State Forest. A lot of hydrologic connectivity targets on Tate's Health State Forest to reconnect what was highly altered over many, many years of activity. There was also some site prep and planning for longleaf and I know y'all in the back can't see the bottom of the slide here, but some erosion control through roadway stabilization. So all in all, and especially if you go out there, you'll notice a lot of low water crossings now that have replaced these culverts that were not so attractive and sometimes not so functional. And this is just the map that came from the Northwest Florida Water Management District Tate Hill State Forest Hydrologic Restoration Plan. So their activity out there built on this prior work with the Water Management District. Now, our part of this, the USDA Forest Service, was really the planning component. Although we did have some implementation, we really were like, okay, well, now what? And by the way, this graphic is kind of a regional perspective, and it doesn't really have much to do with some of this stuff, but I'm going to get into this a little bit later. So how do you conduct a landscape scale hydrologic assessment? Well, we do remote sensing and geospatial, and so everything we do has a geospatial perspective. We're geo-nerds, and we like to apply this to ecological restoration. And so our goal here was to identify and prioritize these hydrologic and upland restoration targets on the Apalachicola National Forest and within the entire region. And then from there, create applicable and transferable geospatial tools, data sets, derivatives that could apply to restoration and be used elsewhere possibly. In fact, one of the things that we did as a deliverable was create a regional restoration decision support system prototype. And we talk about that in the comprehensive hydrologic restoration plan. And this is kind of important because this really is the overall summary of this report. And we had a lot of activity going on here over many years. And I would encourage you to check out this report, and then you can get a better perspective of where we've been and where we're going. And then finally, we did get the chance to implement some low water crossings on the Apalachicola National Forest, taking this eyesore, dysfunctional eyesore, and turning it into something very functional, connecting the hydrology and allowing for the aquatic organisms to pass. But before we started here, it's like, well, okay, now what? Before you start, you got to figure out what you have. And you got to figure out, well, what condition is it in? What is it doing? Where is it at? What's the context in the landscape? And so we partnered with the Center for Aquatic Technology Transfer with the Southern Research Station of the Forest Service. And we created this comprehensive database of hydrologic infrastructure. Well, we had some of that, but basically we started over and said, let's do this right. And so we did it for the entire Apalachicola Ranger District on the forest. And it turned out to be quite effective. In fact, it was the reason why we received money to come in and do these low water crossings. But before we even started, we said we need help. And by the way, this is all about partnerships. We can't do this without partnerships, and I don't say that lightly. We knew that we needed more help than we had horsepower for. And so we reached out to Florida A&M University, and through a partnership agreement, we set up the Center for Spatial Ecology and Restoration at FAMU, basically to foster our mission of, geo-nerddom, to foster sustainable, efficient land stewardship using geospatial technology, really. And along the way, the big bonus here is to train the next generation of environmental professionals. And we have, it's actually working. We've moved multiple PhD students through the program. We have had undergraduate and other graduate students involved. Lots of partnerships, not only with FAMU, but University of Florida and Florida State. So, like I said, we're done with Tate's Hill Strategy 1, and there was a lot, and more than I can condense into this time frame. So I would encourage you to check out that Zenodo link and read this, but this is a lot of what we do. Regionally, we look at this from a digital geospatial perspective. And what's cool is I can tell people we recreate forests with lasers, and we look at it on computers and do a lot of visualization and modeling, and it's a lot of fun. But the thing is, embedded in all this, you can really derive useful structural metrics that tell you what's actually going on across this large landscape, this wonderful landscape. So strategies 2 and 3 are strategy 2 led by the Forest Service with our partners, the Nature Conservancy. I give a shout out to them, and the Florida Park Service, Florida Forest Service, DEP, many others involved in this. Again, partner. And the idea here is to do a lot of treatments, silvicultural treatments, prescribed fire, invasive species, across this landscape on strategic targets that we prioritized in Tate's Hill Strategy 1. And I'll talk about that more in a second. Strategy 3 is actually led by the Florida Forest Service as a private forest landowner initiative to get them involved in education programs on their own land to promote stewardship and sustainable forest management. So all told, we think we're going to leave a mark, and get some restoration done. But back to what we do and what we like to do is the techie stuff and the monitoring. And so we're going to talk some more about that. But first of all, for strategies 2 and 3, this is about this map for now. And the targets we have here, Bluffs of St. Teresa and Little Owl Creek Huck 12 watershed. So I'm going to talk more about this in a second. And I'm not really going to get into this except, this is about 17,000 acres. This is about 30,000 acres. This is mostly dense sand pine that's in need of, restoration badly. And this is wet prairie savannas, a lot of offsite slash pine. So we've already done a lot of work on this digitally. Again, we're out there looking at imagery and satellites. We've got a partnership with the University of Florida with this guy. I'll talk about him in a second. Amazing guy with this technology. And we can do stuff like this, looking at ecological condition, historic natural communities. By the way, this is Florida Natural Areas Inventory data. We integrate all this stuff to come up with things like, well, if we did this activity here, how much water can we get out of it and return to the system that would otherwise be lost to the atmosphere? And we've done some unique things looking at depressional wetlands, and we're going to continue that work with depressional wetlands, particularly in Little Owl Creek. So speaking of Little Owl Creek, this is a strategic watershed, and most of you are probably not aware of Little Owl Creek, but it's a nice place. And it is a place of very high biodiversity. A lot of you know salamanders and, you know, woodpeckers and all the good stuff. And in some cases, the only stuff. And so we take this very seriously, especially with these geographically isolated wetlands, to the point that we're going to be doing a lot of hydrologic modeling across this area to look at the importance of these depressional wetlands for ecosystem services and habitat as well. We've taken this to a higher level in terms of hydrology. Visually speaking, this yellow line here is the National Hydrology data set. The blue stuff is actual, what we've derived on the landscape, and we're even going to refine this further once we get this ultra definition LiDAR accomplished across the forest, that we can fine tune the hydrology across the area. So other things we're going to be doing: SWOT modeling, silvicultural activities, planning for a lot of those in the future, and hopefully getting some accomplished right away. But I can't say enough about this stuff. This is mind-blowing. And it's not about the drones. The drones are cool, but the data is a lot cooler. And that's what we like. That's what we want. And this guy, Dr. Eben Broadbent at University of Florida, he goes all over the world with all of this stuff. You should see his luggage. Man, it's amazing. But he's great, and he's our partner, and we're very glad about that, because we're collecting at this point about 300,000 acres of the most amazing data that you can imagine. In fact, this is the largest drone-borne LiDAR data collection effort anywhere ever at this point. And so taking this data and turning it, these point clouds, ultra high density point clouds, and turning it into structural metrics that we can make sense out of, but not just over a project area, over an entire 300,000 acres across the Apalachicola Ranger District, and possibly Bluffs and, you know, other parts of Florida and Mississippi, Alabama, Louisiana, hopefully Texas too, you know. But we have expanded. We've moved on a little bit in terms of this technology. We had a project out in Santa Rosa County looking at these gullies, erosion hotspots, and using this technology to characterize these pre, during, and post-construction. So that's an overarching view of what we do. And I know that probably didn't do justice to the title of Tate's Health Strategy 1, but if you're interested, you know, give us a shout. You can email us at caesar@famu.edu, or maybe I have time for some questions. Okay. Okay, look at that, 15 minutes, cool. Yes.
Not a question, but a comment. Now we know when people call and they say, there's this guy flying this giant drone over the forest, we know who it is now.
Well, now we have no operational control. Jason and I, the Forest Service, this is through a partnership that we've established. But Eben, wow, you should see this guy. He's amazing. And it is a giant drone. We wanted to go bigger than that, but that's where we had to cap it. Maybe the next round. Yes, sir.
So we're just finishing up a floodplain study where we're using a lot of LiDAR data to just look at floodplain mapping. And one of the things we found is that most of the LiDAR data for floodplains is relatively useless, because all we're reflecting is flooded water sections.
Right.
And of course you want to fly it when there's no tree cover, but that's also the wettest time of the year, especially in the upper basin. So how are you dealing, looking at that as it relates to getting the best valuable data, the best data available for you to be able to look at the systems, because you've got a lot of flooded areas.
Well, it's true. This is very wet here, but there's a couple of things that we can do, and I'm actually going to pass this question off on how do we deal with these flooded areas using LiDAR. I'm going to give that to the LiDAR expert back there.
So short answer is we're trying to be opportunistic, right? Mostly what we've used so far is because we're still collecting the drone data. Most of it has just been the airborne data that's been flown over the whole region, right? So you just take what you get. But you're absolutely right. It doesn't penetrate through water. I'm sure some folks are aware there is bathymetric LiDAR that can go through clear water, but in dark, kind of areas or very deep, you're not getting that either. So what we're trying to do is, especially around like say ephemeral kind of streams, a lot of this data was collected when it was fairly dry, and you're actually getting reliable ground returns. But you do see an area where you have persistent streams that you're not getting data from there. So you just get to the point where it's hitting the water surface, and that's what you got. But you can still improve you can see where the stream channels are, which is a lot of it that was mapped using imagery and things at a nationwide scale. You're getting a lot more detail, as you saw. So short answer is yeah, if you were wanting to optimize it, you would go out there and collect it during the driest season. But over really large areas, you've just kind of got to collect when you can collect, right? But what we're going to try to do too is, instead of like these larger efforts, when we get down to like project scales where we're actually doing work, we can be more selective in when we're collecting the data before, during, after kind of projects for monitoring, because that's kind of where we're moving into with this new phase. So hopefully we'll start getting some improvements like that. Hope that kind of at least touches on, but yeah, it's a lot more could be said.
Time for one more.
So my understanding is with that point cloud, with the LiDAR-based models, one of the things you can get at is sort of like canopy and biomass and tie that to transpiration, so how much water is being pulled up out of the groundwater, and use that to then tune your future restoration treatment so that you can figure out if you thin the stand, how much more water ends up in the river and ends up in the bay, and can you just speak to that relationship?
Sure. Actually, that's good. That gives me a chance to go back to this because these hucks were actually prioritized based on our area-wide basal area product that served as a proxy for evapotranspiration that allowed us to estimate potential water yield gain or return to the system if we did a certain type of silvicultural activity. And so all of these are prioritized based on that. And did we have other things? I don't think I had any.
Just the bluffs.
Oh, the bluffs, yeah, right. This product here is actually potential water yield gain based on stand density and removal to a certain basal area that incorporates our basal area product, which is LiDAR derived, that gives us kind of an estimate of how much water yield return to the system we could expect. So we've done that for the entire region, and we do drill into these projects, particularly like with Bluffs, which is, thick as fleas on a dog's back, sand pine, and what we can expect will return to the system. Now, we can't give you any direction that that's going to go, subsurface, surface, but we are planning projects in the future where we can maybe eke out some measurements on what kind of returns we get.
So I think kind of a broad look at this is it's a tool we haven't really looked at a lot here in the Southeast, right? Which is kind of cool. I mean, we've heard a lot about how important habitat is for wildlife, rare plants. This is another angle, and then also considering carbon. Bringing a lot of this together is something that you can look at trade-offs and look at it for ecosystem services, those kind of things. So it's early days, but we're starting to pull together this kind of. The LiDAR does give us a great look at this.
I know you guys know this, but that same stand thinning treatment should yield benefits to terrestrial biodiversity as well as water for the water systems, et cetera.
Indeed, it will, particularly in Little Owl Creek, and that's one of our primary activity areas. And so we hopefully next talk we'll be able to talk about that. So
yeah,
cool.
Thank you so
All
much.
right.
Thank you. Our next presenter is Ryan Means, president of Coastal Plains Institute, and he will be talking about the striped newt's repatriation in the Apalachicola National Forest.
Thank you very, very much. This is a magical, wonderful event. I am very frequently outdoors, and less often than I probably should am I sharing information that we do at CPI in a public way. I'm delighted to be here. Thank you, ANERR, for inviting CPI. You know what, I'm gonna mind what I do out at our preserve. It's inside of that LiDAR area. I hope you're not flying anytime soon. Our preserve is right in the middle of the Owl Creek deal, and I want to talk to y'all about whether you flew over the preserve and whether I could get that data from you. Boom. Next topic. For about 13 and a half years, my organization and all of its partners have been working to recover a small, cute little salamander called the striped newt. And that is what I'm going to present for you today. And let's see. Who is the blah blah? Is this the deal? I didn't look. Okay. Thank you. Forward and back. Okay. Okay. Thank you so much. For 5 seconds, let's just check out all those partners. I'm not going to read them. It's special. Partnerships are wonderful. That's, again, why we're delighted to be here today. Nothing like this or like anything we've heard about can be done by just a single entity. And we have new partners coming on board all the time. What is a striped newt? Well, what is a newt? Okay, I get this question all the time. I'm going to show you where our study location is, but bikers and hikers come up to me when I'm doing field work, and they talk to me about what I'm doing out there, and the general education level about newts is kind of low. Is that a lizard? And what good is a striped newt? I get that all the time. So a newt is to salamanders as frogs are to toads. And so what I mean is that newts have a terrestrial, granular, dry-skinned phase of their life cycle. There's about 74, 75 thereabouts species worldwide. There's only 2 newts in eastern North America, if you don't count one related to the striped and eastern newt, which is in South Texas. Anyway, they have an incredible life cycle. They're like changelings if you watch sci-fi shows. They literally can change their body, structure and physiology in the course of a single lifespan. They start out as, find the pointer here. They start out as small gilled larvae after they hatch out of eggs, which are deposited in water, mind you, in small, isolated, temporary wetlands that are fishless. That is their breeding habitat. And so they start out as gilled little creatures. They grow, and they have 2 options. They could either go terrestrial, granular here. Look at those little shrunken gill stubs. I love those when I see those. You know exactly that it used to be a larva when you see those. Or it could grow into a large larva inside of the pond, which is this here, retain its gills and grow gonads, either male or female structures, and start reproducing as large gilled larvae. That can happen if their pond does not threaten to dry up, right? If the pond threatens to go dry, they will have to metamorphose and turn into this eft. And so if they go efty, what they do over a year or 2 or 3 is get a little bit larger and turn into, sexually mature terrestrial adults, and we call that the terrestrial adults. At some magic time in the calendar year, which is wintertime, these are wintertime breeding creatures in the southeast, they'll return to their pond in a big heavy rain, typically the one they were hatched in, and transform just a few days after this life phase animal gets to the water. They literally swell up again, grow a tail fin. This is a male with giant Popeye back legs and a big swollen vent. It's just really interesting. This is called the aquatic adult. So I'm going to speed this up a little bit, but I really wanted to show you how cool newts are. The global distribution of the striped newt is really small. And in fact, y'all, there have only been about 160 breeding wetlands ever found in the southeast coastal plain where they exist. That is North Florida and South Georgia. Just think about how small that is. In fact, we probably discovered the species during its decline. Speaking of decline, we're going to get there in a second, but a study in 2011 identified two distinct population segments within the striped newt, and you can see the dividing line here at the Swanee River, roughly. We call this the western striped newt, western haplogroup genetic term, and the eastern striped newt here. Okay, and this is the lovely, wonderful Apalachicola National Forest. Kind of looks like a creature sitting, maybe a cat or a lion with the mane there. In the red is the Munson Sandhills xeric longleaf pine sandhill habitat, where striped newts typically mostly live their natural life history there. They don't prefer sandpine or flatwoods, okay? And so this is their preferred habitat within the ANF. Over here, the Ocala National Forest is its current stronghold with most of the localities for the entire species. But the ANF once had 20 historical spots, and our organization, CPI, discovered that. My father, Bruce, was dip netting out there before I was born, I think, and dip netting continued annually every 5 years, whenever, and then we got way more scientifically rigorous about it. And what we did was we discovered a decline in striped newts in the Apalachicola National Forest, where they once were a 20-pond stronghold here. And so colleagues over in the east, mind you, this is around 12 to 14 years ago, declines were being discovered with striped newts, both in the west and in the east. Mind you, they are more stable in the east, but they're very vulnerable because there's like 60 localities where you could reliably scoop one up in a dip net. And they're being watched closely by colleagues over there. But the west, Lord, y'all, we had data from the ANF suggesting that they were completely extirpated by 2007. And at that time, there was it would be right about here. There was one pond left on Earth that contained the western haplogroup, the western variety striped newt at the time. And so CPI and partners, I'm getting ahead of myself. Why did they decline? Who the hell knows? We've been racking our brains about that and collecting data to try to help us figure out why they went into decline. Other sympatric amphibians that they live with in their area had not gone into decline and still haven't. Thank goodness. Things like ornate chorus frog, gopher frog, barking tree frog, etc. We hypothesize that there is a reason, right? And we hypothesize that drought and Tallahassee water consumption over time is probably the main driver, because the ephemeral wetlands that they breed in near Tallahassee have gone drier and drier and drier and drier and drier over a several decade period. And that's probably, I have to call it a hypothesis now. I know that Tallahassee drinks more and more water, but I need the data. I've queried the Northwest Florida Water Management District, and I haven't gotten a response. Not the one that I need just yet. Are they here? Northwest Florida Water Management District? Awesome. I'd like to speak with you. Awesome, thank you. Habitat alteration, incompatible fire that is not the natural historical fire regime that these animals and everything that they live with are adapted to exist in, and possibly disease. We have done some disease testing. We don't think it is the driver, but we always have to keep an open mind. So in 2011, CPI and partners said, all right, let's do something proactive. Let's help the species. We have an opportunity. With Chuck Hess, former biologist extraordinaire with the Apalachicola National Forest, Chuck and CPI created a proposal to begin a recovery program for the striped newt on the Apalachicola National Forest. And the gent on the right there is John Dunlap. And there is my colleague, Rebecca. Okay, so before we just started throwing salamanders out there, mind you, there were all kinds of things we had to do and consider. Okay? How am I doing on time? I think I was already kind of in a deficit.
9 minutes.
9 more minutes? Thank you. Okay. The first 2 years of our recovery effort, we wanted to really rigorously go back to the National Forest, even more rigorously than we had since the 1970s, and generate some dip netting data that either suggested that we did, in fact, have an extirpation of striped newts there or not. Well, we dip netted the hell out of it. 180 ponds times 4 visits in 2 years. That was some fun field work. All over the Munson Sandhills. And what did we find? Our magic result was 0 newts. And we dip netted during the prime times of the year that you can expect with a dip net to see those animals in their breeding ponds or in their habitat. The next thing we did to prepare for the eventuality of repatriations was go out to that one remaining pond that I was telling you about up in Georgia. We had to knock on Georgia's door and say, hey, Georgia, we need some of your newts, please. And they were amazing. John Jensen was the state herpetologist up there at the time working for the Georgia DNR and issued us the permit to come up, help him get some wild adult breeders from the one pond remaining at that time, big pond, fall line sandhills. With those animals, I spread them out to 2 zoos, and they began creating our captive assurance colonies, out of which we eventually started to release F1 individuals. We keep the parents from the wild as the breeders, and we release the larvae, or I should say F1s. We release their offspring. So, as I mentioned, disease, all throughout this period, we are surveilling the area for disease. We have found things that are expected to be there, but in low prevalence. And some of our disease experts, Matt Gray and Deb Miller, have concluded that ranavirus is probably not a driver for decline out there. We've recently had Arik Hartman from UF come work some magic there too, looking for a broader scope of diseases. He found a couple of hits, but his data also do not support a disease-based decline hypothesis out there. So we're continuing to release. Y'all, if we had disease as an issue, we would pause release. We wouldn't want to release them out there in a detrimental environment. So we had to select places to put them back into, and one of the most important things, attributes for a repatriation pond, was whether or not it also was a historical striped newt pond. With suitable, diverse, herbaceous ground cover, not some monoculture of perhaps maiden cane, which can grow extremely dense and shade out everything and just be the only plant in an ephemeral wetland. Newts, we know, need a diversity of low-lying herbaceous vegetation to take cover in and deposit their eggs on. So if it was a dry landscape, are we going to be successful if we put newts back out into a too dry of a landscape? Well, to address that issue, this is a whole other presentation. At the beginning of our repatriations, we selected 3 ponds to install rubber liners under which to extend the hydro period there. We put all of the sod block original vegetation back on top of that liner. We made it a little deeper, but we gave it a confining layer such that any given rainfall would now be collected on top of the pond and not percolate down into the porous sandy soils, which we showed to be the case with a cool experiment. I don't have enough time, unfortunately, to go into a bunch of the cool details. Okay, so we prepped for 2 years, gathering data, trying to work out the kinks and making sure we had a success pathway. Before 2013, we started repatriating these animals, literally hand releasing them. There's a whole methodology that we have, but you can see at the end of the day, it's all about giving that helping hand to striped newts. And it's a lot of fun, and all of you are invited to come help us release newts into the wild. We just did last week. You might have seen that on our social media. Put all of you on a waiting list. I'm serious. I'm serious as hell. These are some scenes of things that we do to newts, and what repatriations look like and how cool it is to grab a handful of newts. And our colleague, Pearson Hill, biologist, herpetologist extraordinaire, FWC, has run the VIE, Visual Implant Elastomer Marking Program with our newts. He's marked several hundred. We've gotten some data. Talk about that later. This is how we monitor the success of our repatriations over time. This is one primary technique. It's called a drift fence, and we have pitfall traps on either side. We can measure how many newts go into or out of the pond after we know that we release X number of newts into the pond. We can watch them filter out. And then those animals live for months to years in the uplands, and then they'll come back, and we see that happen with our drift fence. That's exciting when you walk up to a bucket and see that in it. And that beetle's cool too. That's the Virginia big-headed tiger beetle. I've always wondered about some of these big invertebrates, whether or not they could do newts harm. This is the other technique, dip netting. There are some challenges. This is not easy work. It unfortunately isn't just as simple as planting newts. They're not as fecund as fish, but there are selected species that dump hundreds, if not thousands, of eggs into the environment. Most of them get consumed. That's the reality of this. In fact, we've only seen a 3.1% occurrence in drift fences after any of our releases. So only 3.1% of the animals that we release are ever seen coming out of the pond. But keep in mind, there's only about 20 females that we have in 7 zoos that are creating these thousands of newts for us. And if you think about that, it's kind of like saying, are 20 females in the entire Munson Sandhills enough to create self-sustaining, viable populations of striped newts and be able to overcome predation and all that? Don't think so. But we're increasing numbers all the time. We just had Zoo Tampa come on board, and Disney is on board now, and they're going to start power raising more and more newts for us. We think eventually we're going to reach that magic number. The real challenge for us is making sure we have several hundred, if not 1,000, 2,000 newts any given year. That's tough to coordinate all the zoos. Sometimes they've got booms and busts in their colonies, right? And also coincide that with a good water year. That's been tough. But amphibians in the natural environment deal with this. Newts have to do this too. We're giving them some help with the liners and with the increase of numbers that we're seeing in our zoos. We're really excited about that, y'all. This is project summary. Okay, this is 12 years of our success. We are not successful yet, but we are reaching early success, folks, at a new pond that we just installed another liner in. The original 3 liner ponds were tiny little puddles. They were never meant to be an entire, wetland that could sustain year after year breedings. Honestly, the puddles were just, for me to the gentleman here, in the white in diameter. They were meant to extend hydro periods and give newts a helping hand in May when their larger pond was going dry, right? Well, we built a much larger liner pond just last year. And that one we're seeing early success at. We've got an 8-month persistence of newts there after our first release back in July of 2023. You guys can read that. I won't read it for us. 5,500 newts thus far released in 13 years. We need it to be 10,000, 20,000 moving forward. We think we're going to reach that number, and eventually we're going to have a coincidence of good water years, and we're very optimistic for success. We do this, and we do that. Rebecca, my colleague, awesome. She has Disney World Conservation Fund money to get the Tallahassee community engaged, and she has put that many people out. And thousands of people, or hundreds at least, have done the helping hand moment. The moment I like the most is the moment of release, of course. Thank you all so much. I hope there's time for questions. If not, I'm here.
You're welcome.
Questions or no?
Okay. Next, I'll be introducing Ken Jones, Project Manager of Rumline Consultants. He will be talking to us today about the slough restoration in the Apalachicola River.
While he's getting all this together. So my name is Ken Jones. It's a pleasure to talk to you all about slough restoration and the work that we're doing in the Apalachicola system. We're between the Bluffs and the Bay. So we start basically at the non-tidal zone, at the top of the distributaries that go into East Bay, and the sloughs that we're working in go up to about Bluntstown. And that's called the middle and lower non-tidal reaches of the system. So we're one of the projects that Sharon talked about. We're part of the Gulf Environmental Benefit Fund through NIFWIF. Special shout out to the Apalachicola Riverkeeper. We're one of the few NGOs that got a project, and it's a huge effort for these small NGOs to take on these large projects, and so kudos to those folks for taking on the risk and the effort to do that work. Need to ask Sharon. I'm missing $400,000. You showed that there was a lot more money on your slide than I actually have in our contract. So I need to talk to you after lunch about that. So what am I doing here? All right. So quick slide about our project team. A lot of what I'm going to talk about, these guys did the work from, and so it's important to recognize all the folks that have been involved with it, and also the continuity of the program. Matt Candolph started with Dan Tonsmeyer, who was a past riverkeeper, looking at geomorphology, the geomorphology of the middle reaches of the system, probably 15 years ago, and that was the precursor to slough restoration. He brought Matt Deach and Scott Walls down as graduate students at the time. Matt is presently at the University of Florida over in Milton. So we were able to bring Matt and Scott back to work on this project. They had such a great background, and they offer such insight to the geomorphology of the river system. We've had 3 graduate students. Jawa Zhu has his PhD. He did our modeling. Alex, you were looking for a modeler. He's finishing up a postdoc. I think he's looking for a job. So we may need to get a hold of him. Really good student. Love Kumar is our water resource candidate, a PhD candidate out of University of Florida Gainesville now, and he should be graduating in December. And John Tracy, a PhD student at UF Milton, is our forester, and he'll be graduating with his PhD in in the spring. So a huge support group. Matt Gangloff is like the muscle guy of the southeastern United States, and Dave Wernicke helped us with fishes and stuff. And all these things go together to help justify the slough restoration work that we're doing. So where did it start? Helen Light and Melanie Darst did a huge amount of work in the late 70s, 80s, 90s, and demonstrated this decline in the number of swamp trees, especially the canopy trees, the tupelo and the cypress and such, and the transition from these swamp species into more of the bottomland hardwood species, the oaks, the hickories, and things like that. And so you're seeing this transition that's related to varying hydro periods in the system itself. A lot of that was caused, well, some of it was caused by the deepening of the channel due to the dams being built, but a lot of that was caused by the dredging operations from the 50s to the early 2000s. So the blue line there is the amount of dredge material that was moved out of the Apalachicola River, 1 million cubic yards a year. That's a lot of dirt, but unfortunately they didn't take it out of the river. They put it in within bank spoil systems, and it was redistributed into other places of the river itself. So they would pile the sand up on point bars and on within banks disposal areas. High water would come, and they would move the sand from point A to point B and then dredge it up. It was basically job security for the Corps of Engineers because they could always have something, the same sand to re-dig up and put someplace else into the system. But what that did was that caused a huge number of obstructions at the heads of sloughs and within the slough channels themselves. And in work done by the Water Management District, they talk a lot about the need to look at the restoration of these sloughs to rehydrate the floodplain swamps within the systems. So the Apalachicola River Keeper wrote a grant. It was accepted by FWC and DEP, passed on to NIFWIF, and they gave us money to do our first pilot project. And through the work that Dan Tonsmeyer and Matt Kondoff and company did, they picked 3 sloughs to do this first work. Douglas Slough and Spider's Cut, which are in the kind of the middle reaches and give us a kind of a small project and a middle project. And then East River, a little different system. It's a flooded slough at the top of the tidal range, but an important slough as it relates to distributing flows to the Apalachicola Bay itself. So we started the work. Well, we were told we're going to get the work in 2019. We actually got a contract in 2020. Did mussel surveys, sediment cores, engineering drawings, surveys, applied for permits, and we're still waiting for permits as we go into 2024. We've been told we think we'll have our federal permits this spring, and we're hoping to go to construction in the fall itself. A lot of work, though, has gone into this so far. It's amazing. We've been on this for 3.5 years. But we have accomplished a number of things. While we're waiting for the federal permits, we were able to get into Douglas and Spiders, and after Hurricane Michael, there was a huge amount of timber downfall. We went in and we did vegetative removal. We weren't allowed to dig anything up. We couldn't dredge. We couldn't fill, but we were allowed to go in, cut trees off at the bank that had fallen over, all the vegetative debris within the channels themselves. And so we were able to clear 2.5 miles of slough. And one of the key things, and what we've always been trying to accomplish, is to work with locals to do this work. So we contracted with local contractors and with Joe Taylor and his group, and they all participated in this debris removal process. Part of what we had to do was demonstrate that the work we were doing would actually be beneficial, solve it. And in the lower portion of the system, we had to look at what dredging of the East River project would be. So that's 2.5 miles, about 30,000 cubic yards, a lot of material, a long distance that had blocked up that section. It's all tidal, so we did a lot of work to quantify the distributary system itself. We did a lot of bathymetry, but one of the important things here is, and it's all about communication and such, but we knew that the ABSI folks were doing a whole lot of modeling in the bay itself. And so we were able to go to ABSI and talk to them about what their goals and objectives are, what our goals and objectives. And so they gave us their model, and then we applied it to the distributary system so that the results of our work could feed right into the bay modeling work that they were doing. Now, our work was highly resolved. We were worried about one little channel way up at the part of East River, but we had to understand all the physics, all the hydrodynamics that was going on so that we could document that once we dredged that, there was actually going to be more water coming down through the system. Now, one of the things we found out was the way we'd been looking at the distributaries all along was wrong. There was a common thought that the St. Marks and the Little St. Marks drove the majority of the flow down to East Bay. Through this work and our collaboration with ABSI, we realized that the East River connector, right there below where the St. Marks comes in, carries well over 80% of the flow, especially at low flow. And so it's going to much further north in East Bay than what we ever recognized before. So through this collaboration, we were able to kind of change the way ABSI looked at the modeling of the bay and the inputs that they were going to have. As an aside, I know the Water Management District is heavily looking at St. Joe Bay, but we were actually able to go back and just play around with this model a little bit to look at some of the assumptions that those guys were making and say, yeah, this actually makes sense. There could be water going up and down through Wimico. So there's all sorts of applications to the work that's been done so far. We also did a lot of modeling in Spider's Cut Slough, and what we wanted to know is when we dredged the Spider's Cut, which was about a mile long, about 20,000 cubic yards of material, were we actually going to be hydrating the swamps more after we did the work than what we did before? And we basically demonstrated by dredging Spider's Cut, bringing it back to its normal conditions, that we would be able to inundate the floodplain at a much lower water level, which is a much lower flow level in the Apalachicola River. But more importantly, that means that it'll stay inundated longer as the water levels start to drop in the spring. If anybody's familiar with the way the Apalachicola work, as we get less and less rainfall, less and less water from upstream, water will stay in that floodplain for a much longer period of time than what happens now. It's blocked, water drains out of it, and it becomes drier much faster, which helps in seeing why this transition from these Tupelo cypress swamps to these bottomland hardwood swamps. So here's some of the modeling. Right now, that dotted round circle is showing where we're getting zero flow, and the upper right corner and the lower right are showing what the slough looks like now. And at Spiders, it's pure sand. There's no silts, there's no clays, there's no organics. This is all material that was in the main stem of the river and has been deposited within Spiders itself. East River is exactly like that too. It's all pure sands, 98% sands, 2% silts. It's telling you that it's coming from these dredge spoil areas. So post restoration, so the orange line is what we're seeing in flows in Spiders Cut, where you can see it drops out to 0. Even at the lowest flows that we modeled, we're still getting 40, 50, 60 CFS going through the system. The channels become open all the time. And at kind of more normal flows, 8,000, 9,000 CFS, we're seeing flows as, in the 200 CFS range. That's a lot of water going through that system. Interestingly enough, we're also seeing increases in flows down through the system at high water. So the purple line is the post-construction, and you're seeing 20, 30% more flow coming down the system. 5 minutes, okay. Post-construction. So it's changing the dynamics. It's returning the dynamics to the way the distributaries used to work themselves. We also, John did a lot of work on looking at the life history of the Tupelo versus bottomland hardwoods and how we may change, we're starting to change the way we look at when and how often and how high we need to inundate floodplains. John should have a paper coming out on this shortly. While we're waiting, we went back in and resurveyed Spiders. It's been 2 years. We're going to have to look at, we wanted to look at whether or not there's going to be a change from a contractual point of view with a contractor. In those 2 years, we've only seen an 800 cubic yard out of 22,000 change. So tiny, tiny little change. So if we don't do something, it's really not going to fix itself, or it's going to take decades to do it. But after we did the debris removal and we cleared it out, we are starting to see the top right, you're starting to see the beginnings of the dendritic processes in these streams. The red is the deeper waters forming on the bends. The blues are the shallower areas. So you're actually seeing the reformation of these channels in the system. As part of the work, and NIFWIF actually asked us to accelerate it, and it's all part of them looking forward to funding. They said, well, this is phase 1. What would this mean? What would we do for the entire reach? There's 12 loop stream systems in the reach between Bluntstown and just above Sumatra in this middle reach that we're talking about. There's about 50 sloughs within those areas. They ask us to go in and look at the full range of all these different slough systems and all the sloughs and put together a rationale and kind of a game plan for doing restoration for this entire reach, because they're starting to look at future planning opportunities. So we did this work and we turned this report in to NIFWIF at the end of last year, and hopefully it will help kind of inform for future funding as we're moving forward. So what are our projections? Our expectation is we'll be able to flood these systems at a lot lower river flows. That's hugely important. We're going to see an increased mussel density. Right now, mussels that are carried in by fish into these sloughs, they die because the sloughs completely dry out. They just don't exist. These will be continuous sloughs all year round. We'll see an increased diversity and abundance of fishes, and just obviously increased nursery habitat and pushing water back to these backwater ponds and wetland areas back in the systems. So Some other things to think about why slough restoration is so important. Dams that were built in the 50s, 60s, and 70s incised the river. It dropped the bottom of the river. Well, by doing so, it dropped the level, the water level for prescribed flow. Now, since dredging is quit, we're starting to see some rebound, especially in the middle reach, but we're still probably 2 or 3 feet. What that means is that removing obstructions from the heads of these sloughs is really, really important, because it already takes a little more water to get high enough to flood these floodplain systems. Now, if we don't remove the obstructions at the heads of these sloughs, then we're blocking that transition, that water back into the system itself. These sloughs, the work that Shanton has done and then redid again through the ABSI program, they've documented the primary productivity, the nutrients that drive primary productivity in the bay largely comes from terrestrial areas. And so if we don't distribute the fresh water into these floodplain systems, and they stay in the main stem, we lose that opportunity to pick up the detritus from the floor of the swamp, and then the kind of the remanufacturing of nutrients through those flood systems. And so redistributing the water or re-engaging the water back into the floodplain is critical from a long-term restoration perspective of the bay itself. We're learning more and more about the swamp species. Maybe drought is not as critical. It's important, but maybe timing is more critical. And I think we're seeing some of the kind of the overlapping of beneficial flows in different parts of the hydro period of the river itself. And so it helps us understand, what would we like to have from the Corps? How could we manage the systems better? Can we give them more concrete information about management than we have in the past? And this is my soapbox, but as part of the ACF system, Apalachicola Bay is not considered part of the study area that the Corps has to look at when it looks at managing the federal reservoirs. So you have the ACF, the Apalachicola Chattahoochee Flint River System. It ends at Pinhook, at Lake Wimico on the Intercoastal Waterway, and the Intercoastal Waterway picks up there. So they don't feel that the bay is part of that project, so they don't consider it in the work that they do. And we need to have that kind of mindset change, because it's a single system. The single system goes from above Atlanta and Lake Lanier up in the Appalachian Mountains all the way down to Apalachicola Bay, and it all has to work together. And there's a lot of stakeholders that are tied to those water resources. That's it.
Our last presenter for this section is Adam Kaeser, fish biologist with Florida Fish and Wildlife Services, and he will be talking to us today about an overview of Gulf sturgeon recovery and restoration in Apalachicola Bay.
Well, we're loading that. I'm with the United States Fish and Wildlife Service in Panama City. The reason why I'm here today to talk about Gulf sturgeon is that it's a federally protected species. That's why we're involved. I've spent some time working with freshwater mussels in the ACF too, so if you have mussel questions that pertain to Fish and Wildlife Service activities, I could talk about that. But I chose this today to talk about Gulf sturgeon because I've been serving for the last 10 years as a Gulf sturgeon recovery coordinator, and that's what keeps me busy these days. Let's just orient a little bit about the Gulf sturgeon by talking about its life history and the important focal habitats that it utilizes over the course of its life span. The fish are anadromous, so they migrate upriver to spawn. They seek hard rocky areas, 100 to 200 miles typically upstream of the bay. where they deposit their eggs in the spring, although more recently we've learned that there's also a fall spawning component to several of the eastern Gulf sturgeon populations, including in the Apalachicola River. So the eggs are released in the springtime, March to May. Those eggs hatch within a matter of days to weeks. Larvae shelter in the rocky substrates and then disperse in the spring. And then there's the young of year sturgeon are thought to be distributed throughout the entire river system. I say thought to be because it's very difficult to actually capture the fish at this stage. And what little evidence we do have suggests that they can be found pretty much anywhere. They're feeding throughout the river in the summer, need to grow in order to survive. And then later in the year, in the late fall to winter, the juveniles descend down to the lower river area to feed in the estuary or in the lower reaches of the river. And at the same time, you have subadult and adult, so the larger sturgeon are moving out into the bays and then into the nearshore Gulf marine waters to do their feeding. And then the cycle repeats. But after spawning, I want to point out that the adult fish, subadult, and juvenile fish throughout the summer will aggregate in these areas we refer to as resting areas. These are very discrete parts of the river that offer the conditions necessary to conserve energy. They're trophically dormant. They're not feeding for about 6 months out of the year. It's actually, this period goes from May all the way to October when they're not feeding, and they're just kind of sheltering in place until they're ready to go out into the estuary and marine environment and begin feeding in the winter. Sturgeon is a cool water fish, so they're happiest when water's cold. That's when they're metabolically active. They don't really like warm temperatures, so they become inactive in the warm summer months. There are 7 populations reproducing across the northern Gulf of Mexico. The Apalachicola is one of those. Why is Gulf sturgeon recovery so important in the Apalachicola? One reason is that this system once supported a very large historic population, which was decimated in the early 1900s. In the 2 years, 1900 and 1902, 165,000 pounds were harvested and reported out of this system, which equates to about 6,000 fish. Some other work by Ahrens and Pine suggested that at carrying capacity, this population once could have supported 16,000 fish, but now with the dam in place, more like 4,000 fish. The point is that there used to be a lot of Gulf sturgeon in the Apalachicola River system, not so much today. But there are other reasons why recovery is important. There are other roles this species plays. It can serve as a host to a few important mussel species, and also through their life history, end up delivering nutrients that are sequestered in the Gulf waters to the freshwater river system, where nutrients can be more limited. This is a picture from the 50s after Woodruff Dam was closed up. So it's impossible really to talk about recovery and restoration of sturgeon without talking a little bit about Jim Woodruff Lock and Dam. This structure blocks access to 78% of the historic habitat of this species in the Flint and Chattahoochee rivers. And it confines the population entirely to the Apalachicola River, where you have a lot fewer groundwater inputs relative to rivers like the Flint. I mentioned cool water being important potentially to the species. There's also a lot less spawning habitat in the Apalachicola River, and it all happens to be located just downstream of the dam. Through some sonar mapping work that we've done, we estimate about 50 hectares of hard rocky substrate exists for spawning of the species below Woodruff Dam, whereas 10 times this amount of habitat exists in areas upstream that they can no longer access. Fortunately, we have a very close working relationship with the Army Corps of Engineers. They are bound to consult with the Fish and Wildlife Service regarding their management of the system, and we regularly do that sort of consultation work with them to try to ensure that the way the system is being managed is not impacting the species. This river system has also been a very high priority of the Panama City Field Office for many, many years, for decades. And as a result, there's been a lot of research and monitoring effort put in toward Gulf sturgeon work in this system, especially over the last 10 to 15 years. These are just some of the activities that have been ongoing, and from 2012 to present, you can see kind of the timeline here. And I also want to mention that, like many of the talks you've heard today, this work is only possible through partnerships and great working partnerships with lots of partners. So I try to acknowledge some of those here. Next thing I want to do is present some of the information that all of this research and monitoring has been generating, and talk a little bit about the status of the Apalachicola Gulf sturgeon population. What I'm showing you here are two data series. In the pink, those squares are point-in-time mark recapture population estimates done by catching the fish, tagging them, recapturing them, and estimating abundance using some modeling techniques. And the black dots and trend line there are an entirely different type of monitoring. We're using side scan sonar to count the fish and then models to estimate abundance. I didn't include error bars here just to keep it clean, but no matter how you look at these time series, you end up seeing a declining trend in the number of fish larger than 90 centimeter fork length. That's about a 1 meter long fish, so fish 1 meter or bigger have been declining in the Apalachicola River over the last 10 to 15 years. Not the kind of thing that you want to see if you're the recovery coordinator for the species. I want to bring in another trend line here. This is the green dots and a green line here showing you annual survival estimates made from acoustic telemetry work on adult fish. You can see that over the last 10, 15 years, survival has fluctuated. Survival, if it's below 89% annually, you start to get concerned about the future of the population. And so you see a few years here where you had some lower survival. And we have at least a couple explanations for some of these events, some of these low survival estimates. In the winter of fall of 2015 into the early part of 2016, there was a very significant red tide event that occurred across the Panhandle that we believe impacted and caused mortality of adult sturgeon. And then, of course, Hurricane Michael in the fall of 2018 hit the system pretty hard and resulted in approximately 50% reduction in the adult numbers of sturgeon in the system. That's well documented in a paper that's been published here. So you see that the survival estimates captured the lower survival in the years, and then the sonar counts captured the decline. The sonar counts made the following year captured that decline in the number of adult fish present in the system. Well, over the long term, survival of Gulf sturgeon averages about 85% annually. And this can be also, this is an important piece of information that can be combined with the fact that we think there are about 100 mature spawning females in this population at this time. That comes from the fact that so you have about 400 fish over 90 centimeter fork length. About half of those are going to be mature based on size structure of the population, and half of those would be females. So that's where the 100 number comes from. You can take these numbers and plug them into a population viability analysis. This is work done at University of Florida by Bill Pine. And let's say our baseline is 100 breeding females with an average annual survival rate of 0.85. This model suggests that in 50 years, you have an 11% chance of this population going extinct. Over a 100-year period, that goes up to a 91% chance of extinction. Again, not something that you want to see as the recovery coordinator. It's a little concerning. What could we do about this? Well, we could try to reduce adult mortality. If we just reduce mortality by 2 percentage points annually, that 50-year probability drops to almost zero of extinction, and the 100-year probability drops way down to below 20%. And if we were to reduce mortality just a little bit and then increase the number of female fish, mature females in the population, we reduce that 50 and 100-year probability of extinction to zero. So the takeaway here is that restoration activities that focus either on reducing mortality of adult fish or increasing the recruitment or production of adult fish in the population would be good strategies to try to avoid extinction of this population and improve its status overall. Well, it can be difficult to identify ways to reduce mortality, especially when the major mortality events in recent years have been these stochastic events like a hurricane or a red tide event. So let's turn our attention to increasing recruitment. What do we know about recruitment of Gulf sturgeon? Until recently, recruitment of sturgeon was not something anyone had ever studied for Gulf. But we did start that about 10 years ago. Also through mark recapture work, so targeting juvenile fish, tagging them, recapturing them, and estimating the number of age one fish that recruit into the population every year. We're estimating them at age 1 because we cannot capture them when they're younger with any sort of reliability. This is sort of the life history timeline of fish from egg to age 1. And on the bottom here is an incredible data series that has been generated through a lot of work capturing those juvenile fish and recapturing them. And what you're looking at is the number of age 1 fish that are being produced every year. So in the early years of this work, we typically saw very low number of fish being produced, around 50 fish per year, with the exception of 2013 producing 200-something juvenile fish. And then in more recent years, we had seen kind of an increase in recruitment, although last year not so much. I find this really fascinating because, again, Hurricane Michael hit at this point in time. It wiped out about 50% of the adult population in the river. And even so, we continued to see increasing recruitment in the years following. It also suggested to us that the hurricane did not eliminate a year class of sturgeon because we caught those fish a year later and estimated higher abundance than we had in the previous years. So what can we do with this information as far as trying to identify restoration opportunities? Well, that's been the focus of a graduate student that recently completed his thesis at the University of Georgia. And basically the question he was after was, is there a relationship between flow and recruitment of Gulf sturgeon in this river? So what he did is, and what we're still working on, is look at each one of these key life history phases, identify some hydrologic metrics that relate, that pertain to the flow in the system occurring at those times, and determine whether or not there's a relationship to the number of age 1 fish that are being produced in a given year. I'm showing you a hydrograph here just from one of those years, but it happens to be the one where we had that 200 plus age cohort produced. And what really stands out to me, if you've ever looked at Apalachicola River hydrographs, is that it was an extremely wet year during that young of year growth and survival period. The modeling work that's been done so far suggests that it's this phase of the life of the young of year fish that has all of the support in terms of a relationship between flow and the number of juvenile fish produced. No support for these other aspects of the life history phase of the fish with regard to flow in the system. And here's what the simple relationship looks like between the number of recruits on the y-axis and the percent of days between June 1st and October 1st when you have flows that exceed 16,000 CFS, which is a level at which 10% or greater of the floodplain is inundated. So when you have a wet year in the summertime into late summer, early fall, you end up producing or observing more fish produced in this system. What's going on here? Well, that's where it gets complicated because ecologically speaking, there are several potential mechanisms involved. For example, greater floodplain inundation ends up delivering more nutrients to the estuary, stimulating primary and secondary productivity, where the juvenile fish are again foraging in the winter period. You could have increased in-river productivity and improved foraging of the young of the year fish in the river itself during that period. You possibly have decreased predation because we know that large predatory fish will get into the floodplain and feed there, where perhaps they're encountering fewer sturgeons. Maybe lower water temperatures when you have a wet year in the summer, and then also possibly access to the estuary for foraging during the summer period. Young of year fish are sensitive to higher salinity, but with greater discharge from the river, they're potentially accessing more of the estuary in the early phase of life and feeding there and surviving. So could be a lot of things going on, but does that really matter? No, because we think we have identified an important relationship here. Knowing exactly how it works is not that important. We can go now to the Army Corps and consult and talk about how we might improve our flows during this critical life history period to produce more sturgeon, especially in years when the water is available. So my last slide, I'm going to try to turn this around to restoration. So When we talk about restoration for sturgeon, there is no easy fix. There's definitely no magic bullet, but there's a lot of common themes that come up. I tried to group those here. Restoring flows, restoring floodplain connectivity, we just heard a bit about that. Improving temperature regimes, all of these things could be important to increasing recruitment of juvenile fish. Restoring access to habitats. All right, we have Jim Woodruff Lock and Dam in the system. This happens to be something that is receiving a lot more attention lately. Is it possible to design a passage project at Woodruff that would allow Gulf sturgeon to access their historic areas? We don't know that yet, but regardless, providing passage at Woodruff would be important to the system for a lot of other species, whether it's successful for sturgeon or not. Couple other ideas that come up, restoring estuary function and the biotopes associated with sturgeon foraging. So if anyone out here is working to develop proposals to do work that would do any of these sorts of things, and they're looking for letter of support or some ideas or anything like that, come and find me. I'd be glad to try to help out with that. Thank you for giving me the opportunity to speak today about Gulf sturgeon. I mentioned some of the papers that have come out recently on this material. There's going to be a lot more in the coming years. Shameless plug here at the end for a documentary film that we just completed last year. It's going to be up on YouTube in the next month or two. It's a 30-minute film about the Gulf sturgeon. It's really cool. This poster doesn't do it justice, but there's a lot of really interesting video footage from the Apalachicola River and drone footage and stuff like that. So keep your eye out for that and check it out. In a couple months, it'll be available. Thanks. Oh, yeah, any questions? Yes, Chad.
Yeah, thanks, Al. In light of Ken's talk, your talk back at Morning Place, successful slough restoration would allow, I don't know where exactly the juveniles sturgeon occupy, but with a slough restoration, if they get more access into the floodplain, into those sloughs, would that provide additional habitat for the juveniles? And could that be a plan for recovery for the species?
All right, that's a good question because to date, we don't have any evidence of young of year fish utilizing the floodplain. That doesn't mean they don't do it, but I don't know of any records of anyone capturing a juvenile fish in the floodplain. And so conventional wisdom is that they stay in the main channel. However, that doesn't mean that slough restoration and floodplain inundation wouldn't confer important ecological benefits that would help sturgeon overall. Again, with the productivity of the system and providing, foraging availability and stuff like that. But I don't know that it's the foraging in the floodplain itself, or rather the stimulation of productivity in the system overall that's benefiting them. It's difficult to know. But we do know from a lot of research that floodplain inundation ends up producing lots of benefits for fish assemblages. You see lots of increased production of fishes when you have wet years in a system like this. Any other questions?
Just one?
Yes.
Other rivers like the Slough, how is sturgeon doing there, and are there efforts ongoing to save them as well?
Right. Yeah, so the question's about the Suwannee River population, which is like our gold standard for a recovered population. There are more sturgeon in the Suwannee than anywhere else. So if there are, say, 400 to 800 Gulf sturgeon in the Apalachicola River, there's like 8,000 to 12,000 in the Suwannee River. And yes, we are working across all 7 populations in the entire range of the species. So we definitely have our eyes on the Suwannee River and love seeing what's going on there.
You mentioned the sort of rocky bottom is important breeding habitat or something like that.
Yes.
Is that habitat protected? I mean, is it critical habitat protected from impacts of human activities? And is there any sort of notion of artificial creation of that sort of habitat?
Right. So the entire river channel is critical habitat all the way to Jim Woodruff Lock and Dam. So it has those protections. But the idea of potentially creating artificial spawning areas is one that is a viable idea, and it's been done for other sturgeon species, but not for Gulf sturgeon yet. But adding rocky material into a river where they would that would provide, the sheltering places for eggs and larval sturgeon has been successful with lake sturgeon and maybe some others. So that is a viable potential option for restoration. Thank you.
All right, everyone, we are at time for lunch. We're going to ask that everyone be back in the room by 1:30. If you are having lunch here, it is being